Welcome back to Algos Made Simple. Got a very easy one today that of course we're going to make as simple as possible. If you have a fundamental understanding of linked list, this is going to be super easy for you. Even if you don't, we're going to make it so simple that hopefully you'll kind of understand what the linked list is doing and you can kind of learn it from this video. But if not, there's plenty of resources out there, very easy concept to grasp. So this is one that we want to be excited about, one that we want to be able to knock out. So with that being said, let's dive right into it. It's Leetcode 141 linked list cycle. It states, given head, the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, position is used to denote the index of the node that tail's next pointer is connected to. Note that position is not passed as a parameter. Return true if there is a cycle in the linked list, otherwise return false. So in this case, I would let the interviewer know, all right, I understand I'm getting the head of a linked list, and I just want to determine if there's a cycle in this linked list, meaning that at some point, one of these nodes links back to a previous node that we've already gone past with the next pointer. So I understand it conceptually, what we're trying to do here, not very hard to understand conceptually. And of course, if you look at the example here, you see 3 links to 2, 2 links to 0, 0 links to -4, and then -4 links back to 2, so there is indeed, in fact, a cycle. Now, if -4 did not link back to 2 and linked to null, or just further on down the list and eventually linked to null, then there would be no cycle in this list. So again, super easy conceptually to understand what's going on here. So how are we going to attack this? Well, in our game plan, you can you've done problems like this before if you've ever done contains duplicate. You just haven't done it with a linked list, so it's basically, let's say, essentially the same as contains duplicate, but just a different way to advance to the next node or number. Just a different way to advance number. So if you've done contains duplicate, you know the easiest way or the optimal way to do it, and I believe the easiest way too, is to utilize a hash set. So we're going to utilize a hash set, which of course we're going to be able to put these numbers in, or these nodes in, as we pass them, and then we'll be able to go to this next node and say, okay, are you in this hash set? And if it is, then we know there's a cycle. If we get to the end of it all, and then we get to the null node or the dot next that's null, then we know, okay, there was no cycle in the setting. So very easy conceptually. So what are we going to need? We're going to need a current variable that's set to the head at the beginning. Where of course we're going to need that hash that we talked about it, so we can call that visited and just have that be a set in Python. What's going to fuel us looking through it? While that current is not null, so to be just while cur, because we're going to keep using that dot next to push us forward. And as soon as that dot next goes from being a -4 to null, or in this case -4 to 2, but if it went to a -4 to null, that's going to have us exit the loop. If it goes that -4 back to a previous node, that 2, that's going to have us exit the loop with the return of true, there is a cycle. So very simple. Again, so much like contains duplicate here. So let's just dive right into it and code it up here. We got has cycle, and we're passing through the head. And of course, I didn't copy in the class solutions, but you know that on these linked lists, they have a property of .val and .next. And of course, you're going to be utilizing that. So I'll go ahead and put that in the game plan too. Utilizing .next. Alright, so again, we said we wanted to have a current variable instead of equal to the head that we're passing through here. So I'll have it be that original node. And then we've got a visited, which is just going to be set, an empty set. And then what we're fueling this loop, we've already said while cur, so originally cur is going to be something. So we're going to have to update that cur to get us out of here. So we got if cur is in visited, because if it is in that visited set, then we know there's a cycle because we've already been to this one before, we've already visited before, so we would just simply return true. Now if that's not the case, then we want that visited and add cur to it, and then what we want to do, because we need to go to the next one, so this is not like contains duplicate where you're running a for loop or whatever and you're going to automatically go to the next number in the array. This is a linked list, so we have to make this cur equal to cur.next, and that's how we're going to get to the next node. And that's going to go through that whole linked list while there's not a cycle. And if we get to that whole thing, there's been no cycle, we're just going to simply return false on the outside. And that's all the code there is to it. It's O of N, super efficient, very, very, very easy, extremely simple. Again, just like contains duplicate. So you set your head right here, cur equals head. You got a 3. Visited is an empty set, while cur, so it's 3. If cur isn't visited, it's not. So we come down here, add the 3 to visited, and the cur is the cur.next, so it gets pushed to that 2. Come up here, while cur is 2. If cur isn't visited, it's not. We add that 2, and we go to the cur.next, which is 0. 0 and visited, no, it's not, so 0 gets added. We go to the cur.next, which is -4. That -4 is not in visited, so we add it in there. And we go to the cur.next, which the cur.next is 2. And we go here and say if 2 is in visited, it is, so we return true. Simple as that. And if it wasn't linking to that 2 and it was just linking out to null, we would get through this whole thing and return false. Can't get much simpler. There is another way to do this problem that some people utilize, and it's very simple as well, and it's got a little bit better of space complexity. So I'm going to do it real quick, but again, I think this is the simplest because it's so much in line with contains duplicate. But if you like this second solution better, it's just good to know, and it may be something that you really get intuitively and something that you might want to utilize. So this is an algorithm called Floyd's tortoise and hare, and all that means is you're going to have a slow pointer, a fast pointer, and you're basically going to see if these pointers ever meet. If they meet, there's a cycle. If they don't meet, then you'll go throughout the whole thing and you'll realize there's not a cycle. So it'll make a little more sense when I code it up, but basically your slow pointer is always going to be going .next, while your fast pointer is going to go .next next, and again, if there's a cycle, they'll eventually meet back. Because think about it like if you had a fast runner out there and a slow runner, the fast runner is going to eventually, it may take a bit, it may take a long time, but that fast runner is going to eventually pass that slow runner if they keep the same pace up, and he's eventually going to lap them or whatever, however you want to say it. So you have a slow pointer and a fast pointer, and we're going to, our fuel for it is going to be while that fast pointer and the fast.next are not equal to null, because we're going to be bumping it up 2, so we need to make sure that the fast and the fast.next are both not null. So with that being said, here's what it looks like coded up. So you got, and of course you still have the same properties, the .val and the .next, but you have has cycle here, and you're passing through the head, and you will say slow, fast, and you'll set them both equal to head originally, because they're at the same starting line, same race starting line, but that fast is going to be bumped up 2, the slow is going to be bumped up 1. So all you have to do on this is while fast and fast.next, so while they're not null, then what you'll do is slow equals slow.next, fast equals, and this is how you make it fast, fast.next, which pushes it 2 nodes up, and then you're going to check and see if slow equals fast. If it ever does, you'll return true. If you get through this whole thing, you get to your nulls, and it doesn't, you'll simply return false. So that's another way to knock this problem out. Either one is fine. Either solution is very simplistic. Again, an easy problem, one that I think hopefully you'll get from these solutions. And if you don't, I think you just need to look a little bit more and research a little bit more about what a linked list is conceptually, because again, this is the same problem as contains duplicate. If you do it the first way, it's just about as simple as it can get. So again, thanks guys for watching, and if you have a simpler solution or you think there's a better way to word what's going on here, something that'll make it stick easier for everybody, please put it in the comments if you're watching, and we'll be back in the next one. Thanks.